Hello guys, welcome to my YouTube channel Technolution Studies. Today we'll discuss how a mosquito zapper circuit works. So basically we will try to understand the PCB board. So there are several components which are getting attached to the PCB board. So first of all, let us start from the right side, then to the left side. So this is the capacitor, which is basically used to smoothen the AC signal. This one also gets is called the capacitor. These are the LED diodes. These are resistors. These are capacitors, small capacitors. Iron core transformer. This is transistor. You can see this is D882 transistor. These are the small capacitors used basically for filtering, and these large capacitor basically used to store the maximum charge. So the question is how it works. So first of all, when we give any AC signal, that means when we keep our bat for charging, first of all what happens, this big capacitor smoothens the AC signal. That means the AC signal or the AC input gets connected to the capacitor. It smoothens the AC and gets rectified by these diodes. You can see there are two diodes. It gets rectified and then it passes through this capacitor. It filters the DC output and then actually it gets stored up in the battery. So here we don't have the actual battery, but I am getting another battery. So I will later show how actually it is getting charged. So first of all, we have understood the basic principle of this part of the PCB board. Then we will try to understand the left side. So basically when the battery stores the charge and we remove the mosquito bat circuit, so what we then do, we press this switch, and if any bugs or any mosquito gets trapped on the mesh, it actually kills them by giving them short circuit current. So how it actually works, so from the battery, when we press this switch, the charge which was stored in the battery gets connected to this circuit. The charge then flows through these circuits. These are resistors, capacitors, again used for filtering, and it finally gets connected to the transistor. The transistor converts this DC signal from the battery to high frequency AC signal, that is the AC signal having the frequency of 3000 Hz, that means near about 4.2 kilohertz. So it is having very high frequency, and this iron core transformer is actually converting the low voltage to high voltage and low current. Then it actually moves from this transformer then to the capacitors, which is again used for filtering the AC signal, and again there are 2 or 3 diodes. It actually rectifies it to the DC, and then the DC signal gets stored up in the capacitor. So when any bug or any mosquito, any type of insects gets trapped on the mesh, the capacitor actually short circuited and provides high voltage, low current. So this is the main working principle of this PCB board. So let us understand it with a basic circuit diagram. I will show you how it actually converts this transistor, converts the DC to the AC signal. Okay, so let us see it. So let's start with the circuit diagram. So the voltage from the battery, when we switch on the circuit, so the voltage from the battery is moving and the charge is moving to this primary core of the transformer, and this one is the secondary winding of the transformer. So when the charge is moving, it cannot flow from this side because the collector is off. Until and unless we trigger the transistor from the base, we cannot the charge cannot flow from collector to emitter. So the first of all, the current will flow from the left side of the primary core. So it will flow from left side of the core directly to the base of the transistor. Now when the transistor's base is getting the necessary voltage, so the collector is getting partially on. When the collector is getting partially on, so the slight current is flowing from the right half of the primary core. So slight current is flowing, so the graph of the current is slightly like this. That means the voltage is getting up slowly. And finally, when the transistor is fully triggered, that means when the base voltage is enough to trigger the transistor, then current will not flow from the base. It will directly flow from the right side of the corner of the primary core. So when this part is getting off, the base is not getting that much current, so the base is getting slowly off. When the base is getting slowly off, current from this side also is slowly getting down. So the graph was slowly increasing like this, the voltage. Slowly it was becoming constant, and when the base was not getting current, so the current was dropping like this. And when again the current is dropping, again due to change in the induced voltage, and again an EMF is induced to the left corner of the primary winding. And when it again happens, the base is again triggered, and again current starts flow just like the previous case, and again current starts to flow from collector to emitter, and again the voltage is getting up slowly. Again the same process occurs, and again when the current is getting constant, that means when the transistor is getting fully triggered, current is flowing from this right half of the corner of the primary core, and the current is flowing like this. So when the current is flowing like this, again the base is getting off because induced voltage is not enough to supply the base voltage, and again it becoming constant, and again it's slowly moving down because the base is getting off again, and again the process begins. So in this way you can see the AC wave is slowly generated, and finally this secondary winding of the transformer is actually step up, just acting like a step up transformer. So it is actually amplifying the voltage, but due to the amplification of the voltage, the current is becoming low, and finally it is being rectified by the half wave rectifier, you can see, and it is getting filtered on the right half of the circuit, and finally it is getting supply in the mesh low. So the capacitor, the main charge is being stored in this capacitor. When a unsuspecting bug fixes or gets trapped in the mesh, it is killed by the charge which was stored in the capacitor, short circuit current which we call. So I think you have understood the concept how the transistor is generating this AC sine wave signal. So I hope you have understood, and if you like this video, please subscribe our channel and don't forget to share this video with your friends. So please subscribe our channel and stay tuned for another more technical videos. So today up to this, goodbye.